Welcome to The Explainer, everyone. Today, we're diving into a genuinely fascinating frontier in residential tech. We're answering a question that honestly sounds a little bit like science fiction, right? Can your home actually make its own drinking water? Okay, let's dive into this. We're going to explore the reality of true off-grid water systems, breaking down the science, the hardware, and the massive shift in how we think about our basic survival needs.
It's a simple question, but man, it instantly shifts your perspective. What happens when the tap runs dry? Most of us are just so used to turning a handle and boom, instant, clean, pressurized water. We rarely stop to think about the vast, super complex, and honestly sometimes fragile municipal grids that make it all possible. We're relying on literally hundreds of miles of underground pipes and centralized treatment plants. But that reliance creates a profound vulnerability. Just think about it. A broken main, a power outage at a pumping station, or a regional drought can instantly turn this endless convenience into a full-blown crisis.
So here's our roadmap for this explainer. 1. Domestic water vulnerability. 2. The physics of extraction. 3. AWG versus traditional wells. 4. The power demand reality. And finally 5. Autonomous habitats. Let's get right into it.
Section 1. When the grid fails, domestic water vulnerability.
Look, there is a massive difference between grid reliance and true independence. Most grid-connected homes just assume this endless, infinite supply of water, right? The municipal system basically acts like a giant umbilical cord. But if you actually want to sever that cord, well, true residential independence requires completely rethinking where our drinking water actually comes from. You literally have to transition from being a passive consumer of a public utility to becoming your own municipal water manager. And to do that, you're going to need the right technology.
Section 2. The physics of extracting water from air.
We pull this off using something called an atmospheric water generator, or AWG for short. By definition, this is a system that extracts potable water from humid ambient air through condensation. And this brilliantly illustrates a concept you're actually already super familiar with. Picture a freezing cold glass of iced tea sitting on a patio table on a hot, humid summer day. Within minutes, the outside of that glass is sweating, right? Beads of water form, they drip down. Now that water didn't leak through the glass. It was pulled straight out of the invisible humidity in the air. Why? Because the cold surface of the glass dropped the air temperature right around it. And AWG takes that exact same physics principle and supercharges it into an industrial-scale appliance, so you can make water at home.
So let's walk through the exact mechanical process happening inside this machine. Step 1. A powerful fan pulls massive amounts of ambient humid air into the unit. Step 2. The machine passes that air over a condenser coil that is chilled well below the dew point. Remember, this is our cold glass of iced tea step. Step 3. The moisture in the air condenses from a gas into liquid water droplets, which are then collected in a holding tank. But wait, it doesn't stop there. Because this raw condensation is effectively distilled water, it tastes pretty flat and can actually pull minerals from your body. So step 4 is absolutely crucial. The machine heavily filters the water to make sure no airborne contaminants made it through, and then it mineralizes it. It adds calcium and magnesium back in so it actually tastes great and is perfectly healthy to drink. It's a beautifully systematic process, isn't it?
Moving on to Section 3. Atmospheric water generators versus well systems.
Now, what's really interesting here is that if you're building an off-grid water system, you essentially have two main choices to source your water. You either look down into the earth, or you look up into the air. A traditional well system is entirely bound by geography. You absolutely have to have a high water table beneath your property, and you have to dig deep enough to tap into it. If the groundwater isn't there, or maybe it's contaminated, well, you're pretty much out of luck. An AWG, on the other hand, bypasses those ground conditions completely. It really doesn't care what's beneath your feet, but, and this is a big but, it trades that geographical limitation for a very heavy energy limitation. It requires specific humidity levels and massive amounts of electricity to run those condenser coils.
Let's look at the objective data comparing the two systems. When we look at upfront cost, a well system can be highly variable, depending on your drilling depth, but it often requires a pretty steep initial capital investment. An AWG is generally a more predictable, fixed appliance cost, though, to be clear, commercial-scale home units are certainly not cheap either. Looking at maintenance frequency, wells are relatively low maintenance once they're established, maybe replacing a pump every decade or so. AWGs, however, have moving parts. We're talking fans, compressors, multiple filters that require frequent, scheduled changes to stay safe. Finally, let's look at drought resilience. This part is fascinating. A severe, prolonged ground drought can actually cause a well to run completely dry. An AWG, though, is highly resilient to ground drought, provided there's still humidity in the air, which coastal or tropical areas usually maintain even during dry spells.
Section 4. designing a residential water independence loop.
Yes, you can make your own water, but we really need to look at how it fits into a whole home system. When you look at the daily energy budget of a completely off-grid home, you'll see standard appliances like your fridge and lights taking a pretty modest slice. Heating and cooling takes a massive chunk, exactly as you'd expect. But the energy dedicated to atmospheric water generation, it's staggering. In a lot of setups, creating your own water can consume as much or sometimes even more electricity than heating and cooling your entire home. Changing the physical state of matter from a vapor into a liquid, especially at a high enough volume to sustain a family, is incredibly taxing on an electrical system.
Which brings us to Section 5, Power Demand, Storage, and Hybrid Energy Pairing.
The reality of this technology boils down to a very stubborn number. There's a remarkably high kilowatt-hour requirement to produce just a single gallon of water. Depending on ambient humidity and temperature, you're spending a significant amount of electrical currency literally just to fill a pitcher for the dinner table. So the crucial point is this: an atmospheric water generator is not some standalone magic box. You can't just plug this thing into a standard wall outlet in a remote cabin and expect to live happily off-grid. Doing that would instantly drain your power reserves.
Therefore, we arrive at the hybrid requirement. True residential independence isn't just about owning a water-making machine. It requires a perfectly paired hybrid energy loop. To sustain the massive power demands of an AWG without relying on the grid, you absolutely have to pair it with a heavy, oversized solar panel array and a high-capacity battery storage system. The sun generates the massive power required during the day, running the AWG and topping up those batteries. Then, those heavy batteries keep the AWG's condenser coils running all through the night, which is actually when humidity levels are at their peak and water generation is most efficient.
And finally, Section 6, From Connected Homes to Autonomous Habitats.
When you put all of these pieces together, you're no longer just building a house. You're engineering the anatomy of an autonomous habitat. It all starts with the solar power array acting as your energy engine. That feeds into the high-capacity battery storage, ensuring a constant flow of power. That power then runs the atmospheric water generator, pulling life-sustaining water directly from the sky. And finally, to make the whole thing truly efficient, you implement an internal water recycling loop. This captures gray water from your shower and sink, filters it, and reuses it for things like flushing toilets or irrigation. This ensures not a single drop of that hard-earned, energy-intensive AWG water is ever wasted. All of these distinct pieces lock together to evolve a standard piece of real estate into a fully self-reliant ecosystem.
We've seen the incredible physics that make water generation possible, and we've squarely faced the massive energy loops required to actually pull it off. This whole concept represents a total shift from relying on invisible civic infrastructure to taking complete, calculated ownership of your own survival resources. It's empowering, it's technologically brilliant, but hey, it is definitely not a casual undertaking. So, considering the intensive energy budgeting, the sophisticated hybrid systems, and the thrill of true, self-contained independence, are you ready to unplug from the grid?